Hello friends, so today we can discuss the second problem from the latest Codeforces round 704, problem name card deck. So in this problem statement, like problem statement told you that you have n cards with you and each card has some value pi written on that, and each value is pairwise distinct, which means that every value is different. Now cards in the deck are numbered from bottom to top, which means that the p1 stands for the bottom card. So this is the bottom card, this is the second bottom card. So the first element is actually the last card in the deck. So the deck is placed like this. Right? It actually plays like this. So this is the P1 card, P2 card, P3 card, and so on. Like as you can see, the cards are like this only. Like the cards are like this. The P1 card, P2 card, P3 card, and so on. Now you actually, what you can do here is you can take some key cards from the top. So let's assume that you take out these cards, and then you can pop out these cards from this whole deck and put them in the same order like this. What I mean by this is, let's assume that the cards are like this: 3, 2, 5, 1, 4. Maybe you take out the first two cards from this deck. So it's like this deck which has these cards. Maybe you take out the first two cards and take out this whole deck like this and put it somewhere else. So it will become like this: 1, 4. Because you take out the first two cards and place it somewhere else. So just take out the first two cards, place it like that. Now this is the new deck which is left. Maybe you take out the first card only and put it again here. So it becomes like this: 5. Then you take out the next two cards, and because the order should be same, you just take out these cards and put it here. So it becomes like 2, 3. So this is the new deck which is formed. Now what you actually want to do here is you want, or actually the question statement define an order of a deck which is equal to n to the power of n minus I into pi. Now this sounds confusing, and it is a summation of all of those numbers. So the new card deck, the order of the new deck is actually this. You can find the order. Now you want to actually maximize the new order, or the new deck which you have to form. You have to maximize the order of the new deck, and thus you actually have to tell that what is the new order. Like what is the new order you can form. As you can see from this deck, which is 4, 1, 5, 2, 3, you can form out the new deck which is maybe 3, like 2, 3, 5, 4, 1. You can form out this new deck. So now you just have to tell that what is the new deck you can form such that this expression is maximized. Now if you first clearly look at this explanation, like this expression, you can see that pi is the value on the each card. Now if you want to maximize this expression summation value, you actually have to maximize this pi and n minus I. Now this, as you can see, if you put n equal to 1, or like I equal to 1, this is the first value, which is n to the power of n minus 1. The second term will be n into n minus 2. So this term will keep on decreasing till when n become, like I become equal to n, this term will become n to the power of 0, which is the smallest term. So the first term is the maximum term in the series. As you can see, n to the power of n minus 1 obviously is the very last term. The second term is n minus n to the power of 2. This is the second largest term, and so on. Now if you multiply this term with the maximum card value, because if you somehow arrange the deck in such a way that the first element in the deck, the top element in the deck, is the maximum element, is that this maximum and this maximum will become the most maximum term. The second maximum term should be multiplied with the second maximum, or like the term which you can find out. What I mean by this is you have to arrange these elements in such a way that the first element should be the maximum, the second element should be the element which can be the maximum if you somehow do this operation, and so on. Thus that if you multiply these terms, it will become maximum. So you somehow want to make the first element the most maximum, the second most maximum, and so on. So you actually have to place them in a decreasing order, as much as a decreasing order as so on, because which means that the first element will be the maximum. So as you can obviously see that this is the first element which is maximum. The first element is the maximum. The second element is the maximum, and so on. So you just actually have to make the element in the decreasing order. The first element should be maximum, but you cannot just sort out the whole array. This is not possible, because you actually have to take, as you can see, this is the stack. So what you actually can do here is you just take out the first element. So the element, this is the bottommost element, which is like 1, 2, 3, 4. This stack look like this: 1, 2, 3, 4, because it's the bottommost element. So you can if I want to make a new stack, what I actually want to do here is I want the first element to be the smallest. Or sorry, actually not like this. Actually, if you tell this is the reverse of this. So what you actually here want here is, if you see here is, you want that the first element, because like this is bottom top, you want that the first element in this is the maximum. So if you want the first element, you want that this goes to the last element. Like the maximum element should be at the last position and the first element should be the maximum. Or what you can just understand from this array is, you just have to sort this from the decreasing to the increasing. So now, as you can see, what you can do here is, if you write it out in this manner also, 1 2 3 4, okay, you can take out the first element and put it here, take out the second element, put it here, third element, put it here, fourth element, put it here, and this is the maximum element, lexicographically maximum. As you can see, now this is also the same thing. If you just put out 1 5 2 3, so you just have to draw the test case to even make it more clear, and you will understand it. So you are just actually given out some array and you have to make it lexicographically maximum. As you can see, lexicographically maximum. So it is 1 5, yeah, 1 5 2 3 4 2 4 3. Now what you actually want is to bring out the first element to the top. As you can see, you just assume it like this only, 1 5 2 4 3. So what you actually do here is, because you want the first element to be the maximum element, okay, if you somehow just take out, as you can see, if I take out this element, what will actually happen is, as you can see, if I take out this element, it will become like this, 5 1, and then maybe take out this as a whole, it will become like 2 4 3, and the first element is not the maximum element. So what the alternative can be, take out the element before it, the maximum before it element. As you can see, if I take out this element, 1 will go to this part, then take out this as a whole, which is like 5 2 4 3, and this is the maximum possible. As you can see, 5 2 4 3. I hope you get the point. So now, how to implement this logic? The logic is also very simple. What you actually have to do here is just take out this array and find out the maximum element from the, as you can see, moving from right to left. Find out the maximum element till this point. As you can see, this is the maximum element. So before this element, as you can see, all this array, you just have to print it out. So as you can see, this element 5 2 4 3, you just have to print out this part only, 5 2 4 3, because I'm moving from left to right now. Okay, and then what is the elements left? 1. So 1 element. So what you actually have to do here is just iterate from like right to left and find out the maximum element. You can see till now, as you can see, just sort out this whole array first. Okay, but just make a copy of this whole array, sort it out, and then find out that, okay, the maximum element in this whole array is 6. So first find out what is the first occurrence of 6. This is the first occurrence of 6, which is fine. So take out all the elements before 6 and put it here, as you can see. Now the next maximum is 5. So move till here. Okay, I have seen 5. So take out all the elements till this, which is like this, because these elements are taken, so only these elements will be. Now the next element highest is 4. So take out this element. So what you can easily do here is, you can just maintain an array of like the elements you have seen till now, and then you can just put it out. But there is one problem in this logic. There's one problem, and then you can understand this whole question. The logic or the flaw in this problem is, as you can see, if I have some array, like let's assume like this, which is 2 and 1 and then 4 and 3. Okay, yeah. Now what you can actually do here is just move from left to right, and then you will find out that the element which is maximum, like you want to find out the maximum element, which is 4. So move from right to left, find out the maximum element, which is 4 at this point. So take out this whole array, which is like 4 and 3. Just print it out, 4 and 3. Then the next maximum element is 3. So you just move from left to right. You do not find out 3. So the element which you find out is 2 1. Just print out 2 1. But this is not actually the right answer. The right answer, or actually if you just take it like this, 1 2 4 3, You just iterate from, like, you find out 4, it is like this, and then you print out like this 1 2. Because you do not find out 3 on the left side of this, what you're actually doing here is just taking out the whole array which is left and printing out the whole array in this format only. But this is not right, because you have taken out 3 only. You just have to find out the next maximum element remaining in the whole array. So what you actually have to do here is, in this problem, in just simple terms, go from left to right, find out the maximum element you can find out till now, so which you haven't used yet. So the maximum element you haven't used yet when you move from right to left is 4, because you haven't used it, because that's the maximum element till now. So you just use 4 and just write down the whole this part. But now, because you have used 3 in this process, the next maximum left in the whole array is 2. So you have to move from left to right till 2. So you just put out this element. Now the next element, which is 1, so you will put out. So the answer will be 4 3, this part, 2 and 1. Okay, but in this process, if you do not take out this, you will put out 4 3 and 1 and 2, which is wrong. So I hope you understand the point here. My point here is actually, because you have taken 3 earlier when moving from right to left in this process, you actually do not have to find out the next 3 in the whole array. You have to find out the next maximum which is remaining in the whole part. Because if you're finding out 3, you will take out the whole array as a whole, this part as a whole. And if you take out the whole array as a part, you will print out the same thing again. But that's the wrong choice. So what you can do here is, you can just make a map. Okay, you can just make a map. And then what you can do here is, when you move from like right to left, just mark out all those elements in the map, or in a set, whatever you can say. You just mark out those elements in the map. Then what will actually happen here is, when you come to this point, okay, maybe, so what you actually have here is, I have an array which is B, which is all the sorted elements. So these elements all are sorted, which is like 4 3 2 1. Okay, so now, because it's the first maximum element, I have to find out from the right to left what is the maximum element. 4, so I have to find out 4. Okay, I find out 4 at this position. Now I have reached 4, so I will find out the next maximum in this left part, which is 3, but I do not have 3, so you will take out the whole array. But that's wrong. What you actually have to do here is, you have to find out the next maximum which is not seen. So 3 is seen. So as you can see, I have an array which is sorted, but I actually also have a map. So element which I've seen. So what you actually have to do here is, whenever I see 3, I'll mark it in map. When I see 4, I mark it in map. So when I see 4, I see that, okay, 4 is the next maximum I've seen. Then I iterate from left to right and find out the next maximum element which I haven't seen. So when I go to 3, I can match it in the map, and I can show me that, okay, I have seen 3 earlier, so I don't have to use the next maximum 3 in this process. So I will not use 3. So the next maximum which I haven't seen is 2. So next I will find out 2 in the remaining part. I hope you understand the logic of this problem. I'll take it on to the code part now to even make it more clear. The code will be in the description, so if you have some problems, do let me know. So what I actually do here is, take the input of A and B. This is the taking the input of all the elements. B is just a copy of that, so that we can sort it out, and this is a map. So just initialize all the elements in this A, and also B is the same of A, and also initialize all the elements in map with 0, which means that I haven't seen anything yet, like I haven't used anything yet. Then sort out this copy of A vector, and this is a pointer with J, which moves along the maximum elements on this B. Then what actually you have to do here is, I have to iterate over this whole A vector, which is the original vector. Okay, and then I have to match this current element, because see, the maximum element I have to find till now, like the maximum element I have to find which is not seen, is in B, because B stores all the maximum element. So I will make a element J, point at B, and check that, okay, the maximum element till now which I haven't seen is this 4. So I have to find out the first occurrence of 4 moving from right to left. When I find out the first occurrence of 4, I will take out all the subset which I have seen till now, print it out. Else I will mark out all the elements which I have seen till now in the process. So I have to make an empty vector in which, if both of the AI and BJ, which means that because BJ is the maximum element which is not seen till now, and AI is the current element, if they are not seen, then I will push back this element, because see, I have this whole array. I have to take out this whole array as a part and just print it out. So I have to make out or actually bring out that whole subset. As you can see, this is 3, 4, 5. So I have to take out this whole part as a whole and just print it out. So that's what I'm doing, taking out this whole part which is not matching in this C vector. Okay, and also because I'm taking out these elements, I have to also mark it out in the map. Else, when I find out the first maximum or the maximum which I'm searching for, I will push that in this vector and then mark it out also, and then print out that whole section, which is the section. And then because I've printed out that section, I will have to make this vector clear. And also what I have to do here is I will do a while loop to find out the next maximum which is not seen. So if I've seen some element, I will mark it 1, but if I do not see it, it is 0. So while this, the new j, the current j, which is the maximum element in B, if it is seen, I will iterate j plus plus j plus plus. If the first element is which is not seen, we'll find it out and then we'll use that next maximum to do the next for loop. Okay, and then after the whole process, maybe there is some elements more in C which are left, obviously, so we have to print that out also, and then that's the whole problem and the solution. If you still have doubts, you can mention in the comment box. I will be happy to help you out. You can also contact me on my Telegram channel. So let's see what will happen, and I'll see you next one. Till then, keep coding.